Good evening, and it's great to have you all back at Polkadot India's Substrate Saturday Bootcamp. And this is the final chapter of the series that we have custom designed for you. And this is a highly competitive Rust and Substrate training series for all of us ambitious developers today, right? Today's session is going to be an ideal recap of what we've covered so far with the curriculum, with more hands-on coding to nail it all down. So even if you have not been a part of us in the previous sessions, then I think this is still going to do some good to you. And for our first timers, please note that we have an exclusive for developers only. So do fill in the form as in the chat box, and please stay connected. And you can also recap the previous sessions on our YouTube channel or on the Discord channel itself. Okay, guys, a quick game, and you have the next 12 hours to do this. Follow us on Twitter if you haven't already. Quote tweet that you are a part of Polkadot India Substrate Saturday today. And the best 5 quote tweets win 50 USDT worth of dot each. So guys, this is an easy one. Just help us get out there in the world and say that we are all together in this and growing together. And I think it's going to do some good to you too. And for those of you who were at our blockchain gaming chapter of Dot Friday, we've got our winners, and you can check for your dot wins soon. And in the March edition of Dot Friday, that's on the 25th of March, let's dive right into the metaverse. So that's the theme. So check out our pinned post on Twitter again and join in right away, because that's going to be quite exciting, to be honest. And for the fun part of this boot camp, guys, we'll also be shooting out some quiz questions basis what our mentor covers today. So stay attentive, because these quiz questions and your right answers can again get you some airdrops of dots. And all you have to do is just respond to those, shoot them at you, tagging us at _Polkadot India. Okay, 3 winners for this per question. And this is simply so that you keep coming back each time and just stay interacting with us, right? Now, Substrate, guys, is the modular blockchain framework which Edgeware, Kusama, Polkadot, all of them are built on. It's been built, it's been created by the whole innovators of the Polkadot system altogether. And the foundation of the whole system, is kind of based on this language. So Substrate allows developers to quickly and easily build blockchains optimized for any use case. And I'm sure all of you here already know that, right? So that's what we are here for, to give you guys, all of you skilled and desired developer base, an edge over many, because with a focused training, this booming programming language can actually do wonders. So let me not take too much time and finally give you your mentor and the curriculum designer for the evening and the entire series. That's Varun. Varun, all over to you to kickstart today's session. Yeah, looking forward.
Well, thank you so much, Ananya, and welcome everyone for this final bootcamp of Substrate Saturday. This is the last bootcamp, and there would be some amount of recap that what all have we done earlier, and also some hands-on coding with an extensive knowledge of how to even write a palette from scratch. If you guys were not part of the previous bootcamp session, so not a problem, but we would advise after this session also, please feel free to reach out us on Discord via the questions, and also go through all the material that has already been provided to you, because this is first-hand crafted and designed purely keeping bootcamp in the mind for first-time developers on Substrate. So it would really help you and guide you in order to kind of build a Substrate-based chain. So I would quickly share my screen. Here we go. So yes. Again, for the first timers and probably for the people who are joining it for the second time or third time, I would like to repeat a couple of points. So what is Substrate? Substrate is a framework, as already Ananya had mentioned. So this is required. Okay, let's say we have multiple frameworks for developers to kind of quickly call those APIs in order to kind of customize the logic further for your business use case. Business use case as in for a developer's use case. So similarly, Substrate is a framework which is already written in a language which is Rust. It is written on top of it as a wrapper. All of the interfaces, all of the trait types, and all of the generic types which are written for Substrate are actually implemented the way it is actually written in Rust itself. So not much of a difference over there. But when it comes to writing a blockchain, so obviously you need some help in order to, kind of add information in a specific block, right? You need a consensus algorithm. You need to worry about the security. You need to understand how to ping from one node to another node. Now, all of this, like the security, networking, and consensus, if all of this is already pre-coded for you and provided to you, so that you can just worry about the business logic or the main logic of your chain, the way you want to customize it. That is what Substrate is for. So yeah, by the way, I already answered the second question. I said, so why do we really need Substrate? For quick development, for quick hacking. By hacking as in for quick customization of any given code base to you. You fork this Substrate node template. So there is a template which we'll cover. And on top of that, you can customize it based on your logic. Rest, everything would be taken care by Substrate on its own. Okay. Now, the third thing is, what is a frame? So frame, as it is already mentioned, framework for runtime aggregation and modularized entities. So whenever you are writing a class in any specific language, which is an object-oriented language, right? So you would be writing a class, you would be writing functions. So all of these packaged together into any specific package or a module. That module can call any other module combined together to provide an entire logic to your code base, correct? So one class can call another class can call another class, and then they could inherit from each other also, right? So this is what frame does. Frame has already pre-compiled, pre-written palettes, or I would say templates, which ideally help you in order to, quickly rig up the entire runtime logic and make any changes or append any logic to it further. Okay, so so the way we install Rust in our system, we need to install Substrate, and this is the link from which you can actually go ahead and for any specific type of machine, you could just install these dependencies. I would personally suggest, whenever you are installing a Rust tool chain, try to have it nightly by default, unless and until it is explicitly mentioned by Substrate team that you need Rust stable version for this, because Substrate code base keeps constantly changing as per the Rust versions, which is keeping updated. So sometimes it might throw an error. So it's better to always have it nightly, but once your code is set, shift to stable so that it has a stable version of Rust by default for your Substrate. Okay. Now, after installing these dependencies, now we'll understand the basic structure of Substrate. Like we have been talking a lot about Substrate as a framework. Now, when we talk about a framework, so obviously, if we talk about an operating system, or if we talk about any particular machine, let's assume whoever is comfortable with Windows. So Windows has a structure like C drive, B drive, E drive. C drive is further divided into folders, right? That folders are further divided into files. So that is nothing but it's a structure or a framework for that specific drive. So whenever you are writing a code, obviously you need to understand where each and every file belongs to, which specific type of a file could be combined together any specific module, and this specific module of mine could belong to any specific folder. So this is how any framework is ideally designed. So we would go ahead and understand the Substrate code structure. This is okay. This is a pre-compiled code that I have actually taken from Substrate code base. So you can find it over here. I'll share the link. So just go to substrate.dev. Okay. I will keep adding it to the chat. So if you guys, while I'm making you all go through all of this, if you want to, go hands-on along with me, please go ahead and, kind of start downloading this stuff on its own. So there is a link known as substrate.dev. Inside that link, you have under developers heading, you have multiple headings, which is how to guides, tutorials, Rust talks, and playground, right? So how to guides is going to explain each and everything in detail about the framework. like why do we even need any macro? Why do we need any specific trait type? Why do we need this palette also? So these are how-to guides. And then for the first timers who just want to understand how the logic flows, there are tutorials. So for example, under tutorials, you have create your first substrate chain. So if I click on this create your first substrate chain, it would walk you through each and everything step by step, making you understand about the logic and also how to utilize this tutorial. So when I say utilize this tutorial, so I told you, right, you can install Substrate and you can install Rust. So these are the required packages which every point over here will try to explain it to you for any specific type of an OS. So you install all the dependencies, which is the Rust dependencies. As I said, install Rust and Rust toolchain. You get all of these over here, and you update the current version. And now when we talk about Substrate, so for Substrate, you have to have a development friendly environment, right? If the previous link that I showed it to you, you need those Substrate dependencies. Once you have downloaded those Substrate dependencies, this is the base template, which is known as Substrate node template. You can clone this entire repo, and the moment you clone this entire repo, this is what you get. Substrate node template. Let me just show you the entire folder structure over here. So inside this Substrate node template, you have a node template palette, a template palette. Then you have a folder which is target, which actually manages your binary and the wasm logic. Okay. Then you have the cargo.toml. This cargo is basically to have a conversation with your package manager, which is cargo. So Rust uses a package manager separately known as cargo. Okay. The way you give commands for your npm, which is a node package manager. Similarly for Rust, you have cargo package manager. So cargo obviously always looks for a specific type of a file known as cargo.toml. And the moment all of the dependencies or all of the packages which are coming. So for example, when you are running a Node.js kind of a code, right? You need npm package manager to install those dependencies in order to run your Node.js code. Similarly, via cargo.toml, you are explaining all of the dependencies that you need in order to run your Rust-based code. So once all of those dependencies are generated and created, then it gets logged with a specific version that you have provided in your cargo.toml into a new file known as cargo.log. This is auto-generated. You don't have to worry about it. This is taken care by the cargo package manager. Looking at the cargo.toml based on the version that you provided in the cargo.toml, it would generate. So because when you are doing a cargo build, so it would actually look at this log file for a specific version. Okay. So this is where it looks at. Next, these are the three important folders: node, runtime, and palettes, where entire logic of your chain is mentioned. So we'll quickly go to that, and I'll try to explain it to you via the code structure. Okay, so now you see overall, this is a provided template by Substrate itself. We'll understand this in detail. Okay, so there are three folders. One is node, where, okay, the one is palettes. I'll explain about the node. One is palettes. Palettes is basically your runtime logic, your business logic, where the developer is going to, kind of write logic in order to communicate with the chain. From the, so there is something known as extrinsics. Extrinsics is nothing but a call. Call is nothing but a function. So basically, when you want to call a particular function from out of the chain, which is within the chain to do something on the chain, so you call, that is a dispatched call. A call is being dispatched via your chain to make an offline communication to that specific function call. That all the logic is written inside palettes template. Okay, so you have your lib.rs file, which is by default currently open right now, which has an entire structure. We'll cover this also. But again, I'll just explain that overall logic of your runtime is mentioned in a specific module. That module is nothing but a palette. You can have multiple palettes within a single runtime. Now, what is a runtime? There is a separate folder known as runtime. So runtime has a lib.rs again. In this runtime, you are going to mention, so as you all are aware of macros. So construct runtime is a procedural macro, which is written by the team of Substrate. We would cover this also in detail. Now, whenever you are, okay, so when you are trying to compile a particular code or a package, so in that package, you are going to say, okay, I want to add this class. I want to add this class also. I want to add this class also, class 1, class 2, class 3. So, and combine all of these 3 classes together into a single package to provide it to me for the final deployment, right? So runtime is nothing but your final deployment, which you are going to provide to your cargo package manager. That in my runtime, I would be mentioning all of these palettes. So inside this palettes folder, you can have thousands of palettes, you can have hundreds of palettes, but you want to include only 5 palettes or 10 palettes currently into your chain, okay, into your runtime. So all of those 4 or 5 palettes that you have written separately goes inside your construct runtime over here. So this is the overall structure of runtime. Now runtime is a pretty lib.rs of runtime is a pretty big file. We'll cover this also step by step, but I just wanted to show you that if I want to include this specific palette, which is palette template, correct? How did I get this name, palette template? The palette template name that I got is from my cargo.toml, which is this, right? So the name that you see over here in your cargo.toml, so this is nothing but this is your package. So you are talking to the runtime and saying, listen, I want to include this specific package in my runtime as well, which has the name palette template. And this you can say as an alias template module, as an identity of this specific palette template. So this becomes your identifier via which you are going to call any of the logics which is mentioned inside this palette template. Okay. Now, this is all about construct runtime. So this is how runtime and palettes make a communication with each other. But now, if, okay, we won't go deeper into if you have multiple runtimes. Let's say you have a single runtime at the moment, which is your business logic. Now you want to tell your blockchain, your node, which is going to actually, kind of handle the transactions and include all of the logic or the binary logic or the hash of your runtime into a block. So you need to provide that information to a new folder, which is known as node. So inside node over here, there is a file known as chainspec.rs. This is nothing but chain specification. Over here, for your chain, you are specifying that for a specific node, what all do I need to include from my runtime? Okay, all that logic goes inside this chainspec.rs. So this, the moment, okay, so as I said, you at a personal level, when you're rigging up this chain, you don't have to worry about the node logic. You even don't have to worry about the runtime logic. Ideally, you just need to tell in the runtime, in your runtime lib.rs, that I want to include this specific palette. Rest, everything would be shipped to your node folder, which is basically the blockchain node, which is trying to communicate with your runtime. Okay. And then, okay. By the way, any questions up till now? Or am I going too fast, or like, is it okay? The speed is fine. Just let me know, guys, please.
For a non-tech person, I think even I'm understanding you, Varun. So I think it's a great pace. Just in case anyone has any queries, do feel free to speak up, please. No shying away.
Okay, cool. Thank you, Anana. That's a confidence booster for me then. Okay, so as I said, now when you are talking about your business logic, so you need to just write a simple class. Class is nothing but your overall module, the logic that goes inside a specific thing known as palettes. So Substrate basically calls it it has palettes. Otherwise, in normal languages, you can call it as a module or a class. Okay, don't get hard bounded with the word class, but it's a generic definition that inside a class you have a lot of logic in order to communicate with each other, right? So similarly, palette is in a structure which is written by a team to provide that complete flow. Now, whenever you are writing a palette, so there are some frame crates. So as I said, substrate team, we already mentioned it over here. I'll just go back to the previous slide. Okay. Over here, I was explaining it to you, like it's a framework for runtime aggregation and modularized entities. So modules, entities, aggregated them together into a runtime to create a framework. That's frame, right? So the substrate team is providing you that frame support. Okay. By frame support, what do I mean? That all of the pre-compiled or pre-written logic is given to you via a special package known as frame. Crate is nothing. Crate is a package. Okay, like the entire thing is shipped to you. You can keep calling the modules or classes or functions from that particular package. That package is known as crates in Substrate, and the frame is a structure via which you can call any specific crate in order to call in your class. So these are pre-compiled classes written by Substrate team to provide it to you to link in your palette also. Okay, and then there are macro attributes. Now, what are macro attributes? I'll cover this in detail, but macro attributes are very developer friendly, I would say, because when there are 1,000 lines of code or something which is being repeated again and again, right? I understand now you will say even the function is the same thing. Yeah, but in the function, you can keep changing the logic, right? Once your macro is exported, so that information is included into your metadata. Metadata is something which Substrate node needs regarding a particular attribute that, okay, now for a specific type of function or for a specific type of a type. Now, when I say type of a type, as in enum is your type, struct is your type, unsigned integer is your type. Now, all of these types are given maybe sometimes a different attribute, which is a macro that should follow a certain rule or a certain procedure before even giving it to my function. That is what macro's job is to do. So as a developer, it becomes really easy for us to, kind of do that checking or, calling of that extrinsic functionality, which is lying down somewhere. So the Substrate team has written a lot of extensive macros, which you can definitely keep calling in order to provide that checks on the extrinsics or on the types. Okay. Now, I've been talking a lot about functions. So functions in palette is nothing but a call. Okay. There is a keyword. The keyword is the call itself. Whenever any extrinsic or any function is being called from off the chain to perform some action within the chain, to update any information or to insert any information or to provide that transaction hash or whatever, that is known as a call, and that itself is also known as a function. Now, every function obviously has return types. It could return a value, it could return the string along with an error or whatever. So there are multiple return types. One is result type, the other one is dispatch result. Then there is dispatch result with post info. Post info as in, so when you're doing dispatch result with post info, so it would display the result, it would dispatch that result also along with a function as a callback to be given via that result. So the result is generated. Okay, fine. That happened via the function, but it also provides a callback function if you want to include. So you use dispatch result with post info. Okay. Now, we have covered a lot in detail. So I would just give a definition again of traits. So a trait is a very, in a simplistic manner, I would say, trait is something which you would end up utilizing to provide inheritance logic to your code base. As simple as that. Now, I believe I would have used this example earlier also, but I like this example, so I will repeat it. So if my father has some properties, okay, and I want to inherit, so now I'm still bounded with my father, right? So whatever properties my father is providing it to me, I can have few more properties other than that, but those properties also belong to me. Correct? By properties, as in it could be anything. let's say a land or gold or whatever. I can still buy silver, but I can still hold gold and land, right? Those are different types that I can still hold. I can either make changes to this by overriding. I can increase the gold amount. That was a different type, which was given to me by my dad. But when my child also comes, so not only is he inheriting the property from me, he's also inheriting my father's property, which will also pass down to my child. That is what trade's job is ideally to do. Okay, I will just read it out for you again. So a trade basically tells the Rust compiler about functionality of a particular type, what that particular type has as a functionality, and can share with other types. As I told, pure inheritance. Now we can use these traits to define shared behavior in an abstract way. We can use trait bounds to specify that a generic type can be any type that has certain behavior. Now, this line, I'm sure, could be slightly tricky for anybody understanding traits for the first time. But as I said, I'll explain it to you in a very simple language again. So me, my property, and my behavior is bounded with my dad's properties also, right? In the entire structure, I can still bound my property, my functionality to my dad's functionalities or my dad's properties. So I'm bounded with whatever my dad is also providing it to me, right? I can still override that. So that is nothing but that is known as a trait bound. Okay. Now I can be only bounded to one type, or I can be bounded to multiple types of traits or the functionalities which are there. I could be bounded to my dad. I could also be bounded to my mom if they have separate things. But if I don't want to be bounded to my sister, then I don't need to mention that separately. I just need to mention that, okay, trait Varun is bounded to trait dad plus trait mom. Okay. Did that make sense, or any further explanation needed on this? I might have went slightly deeper, but any comments on this? If you guys need me to explain again, I can definitely go ahead.
Hi, Varun.
Yeah.
Just want to confirm if I can understand that traits are basically interface in any language.
Correct.
And bounds are like generics. So
Correct.
you are just explaining the stuff. I understood correctly, no? The traits
Yes,
are
yes,
interface.
correct. I just wanted to keep it slightly in a normal generic language at the moment.
Okay.
Cool. I'll move forward then.
Absolutely.
Sure. Okay. Now I showed you a file in runtime which is known as lib.rs, right? Now we need to implement the traits. So we would go deeper while actually implementing all of this, but I want to give you an understanding of the Substrate code structure. So this is the template palette that we have, right, in our palettes. This config that you see, this is the name of a trait that you have written inside your palette template. Now I am saying I want to implement this palette templates trait for runtime. Now the runtime that we mention over here is nothing but a enum. It's an enum type. Okay. So this is pure substrate structure. So block is basic. Okay, I won't. I will go step by step. Sorry. So after that enum. So these are the types. Over here you see type event equal to event. This is a type that you are saying in your runtime that I want to implement the configuration trait for this specific type of an event of this specific type for my runtime. Now runtime over here is your enum again. Now when you, so I was explaining it to you about procedural macros, right? So construct runtime is a procedural macro. Okay. Let me actually tell you even how to, understand because see, it's a very vast code base, Substrate. So it's always better to, kind of go through their API docs when you're writing something or when you're learning something in detail. Okay. So I'll go to this and let's understand what is construct runtime trying to do. Okay, so see, as I said, frame support is provided by Substrate team to, it's a support of the frame framework to provide you that all the aggregated logic. Now inside that aggregated logic, you already have a different macro, which is known as construct runtime. Okay, inside construct runtime, which is a procedural macro, we saw the code that I was demoing it to you in the example, that pub enum runtime where block is equal to block, node block equal to node block, unchecked extrinsic equal to unchecked extrinsic. This is Substrate's definition, but at the end of the day, if we understand logically, so we are trying to say that this block is of a type block which is already defined by Substrate, okay, in the runtime. Now, node block is basically the block type that is used in the node, but this block type is something that is used in the runtime. Okay, now this block and this block, they both are coming from a different place. This is coming from node. Okay, so as I said again, I'll repeat it. So this node block is the block type that is used in the node, and this is the block type that is ideally used in the runtime. And unchecked extrinsic is something which is to provide that signature or for a particular call, which is an extrinsic call that you are writing, right? So you pass it as a parameter of a type which is known as unchecked extrinsic. And this is how you are going to say that I want to construct the runtime of various combined together with this information inside the nodes block. Okay, all of these packets together, I'll just repeat it again because this is important. So when you say construct runtime, Substrate basically looks at this macro. Okay, now what it is going to do is it is going to compile whatever is mentioned inside the runtime. Okay, any specific type of a palette with any specific type of a functionality, okay, into a single block via your runtime. That is known as construct runtime. It is very verbose. So construct runtime on all of this logic. Okay, so these are different palettes: system, test, test2, and all of these are different palettes. And in earlier versions, before frame, so currently we are in frame version 3. In frame version 2 and frame version 1, if you wanted to include any particular types defined in your palette, you always used to explicitly mention palette, call, event, or you always used to explicitly mention the type that you want to include. But now in the latest update that they have, which is I believe 0.9.16, over here, if I go, you will see slight difference in order to mention. Okay, see, inside template module, they have just now mentioned it as palette template. Now we don't have that, the implementation separately written for palette, call, or anything. We are not mentioning that palette, call, and anything over here, because now this construct runtime is an advanced version which automatically takes care of your palette by getting all of that information with a keyword known as palette. Now with a keyword known as palette, so inside this, see, whenever the construct runtime, the macro is going to compile your palette, it would just look for this particular word now rather than storage separately, event separately. So it would just look for palette storage, palette. Palette already has storage. So via the storage, whatever the name of the storage is, so this is basically the name of the storage. Get me this storage in which the logic is stored or the values are stored. Okay. Similarly, then there are multiple things: palette call, palette error, palette event. So now it is just looking at this rather than separately looking at error, event, config, or any specific type, which earlier we were mentioning in our lib.rs over here, like this. Now we don't do this. So you can ignore this. Okay. So this is what a procedural macro does, construct runtime. So as I said again, you don't have to worry about this. Substrate has already provided these macros to you. You just need to understand how to utilize these. Okay. Now going back to your construct runtime. Okay. So this is how you were able to implement any specific trait, which is your own trait for the runtime enum. So where did you actually make the change? You didn't make change anywhere. You just implemented this new palette for the enum runtime, which is going to wrap it with a block with this specific information. That's it. Rest, whatever is going before this and after this, we are not worried about it. Okay. Now, trait bounds. So the important part. So as I said, frame provides you different type of traits. Now, this config that you see, this config, this is coming from a different package known as frame system. Frame system is a trait which is providing you this trait, and this trait config, this is my trait that I am going to write with all of the different types and then all of the different functions which are going to utilize these types. Now I am saying whatever I want to type, whatever I generate over here is still bounded with a version or with a definition provided by frame systems specific trait config, right? So we will cover this while coding, so you'll understand this in detail. I'll go to the next one. Now, when it comes to generics, okay, generics is something, okay, it is as simple as when you're trying to say to your Rust that, okay, I want to add two numbers which are of U32 types. And then, so you wrote a function add A and B, where A and B are both U32 types. So it will just add those particular values together, right? When you want to change that particular value to U64 or F32, so you will have to write another function again, which is going to do add A and B, which are of type U64. Then you will have to write one more function, which is add A and B, which are of type F32 or F64 type. So you can't keep writing too many functions for different types. So what happens is, to your function, you actually tell, okay, listen, I am going to write a generic type. So in Rust, ideally, what I have observed most, you can write any word, any character you want. It's not only T, you can write U, E, V, whatever. But there is a reason probably that for a type to be generic, so they call it via T as a type itself. Okay, so this is a generic type. So as I said, this particular function foo, which is of a type T, is going to take two arguments, 1 and 2, which both are of type T. Now, when do you actually define that this particular type T is my U32? You can mention it in your runtime, as I mentioned, or in if we talk about Rust, you can mention it in your main file that this specific type T is of type U32. So you still have a single function, but whatever logic you want to change, you change it in your runtime or main file. So this is how Rust takes generics. But for generics to be taken by in Substrate code, so what they have done is we created a trait which was config. So in Substrate, ideally you implement a type, but you also bound it with a specific trait. So for example, because my types are ideally in Substrate mentioned inside a trait. I showed it to you, right? Trait config, which was dependent on something, then it had a type event and whatever types you are going to define next. So I am actually giving for this specific structure, which is palette, a generic type T, but this generic type T is actually of type trait, which in itself would provide you all the types. So that's how you actually write a generic kind of code in Substrate. Okay, I believe I already covered this. I jumped. So there are multiple declarative macros and attribute macros. That attribute macros are something which I'll show it to you, and also declarative macros while we code. So these are written for any developer to save their time to perform all the checks on the macro, rather than just doing 1,000 lines of coding, and it keeps you don't have to repeat that logic again and again. You just store it into a particular macro, you export that macro is going to run against the entire logic to check via this specific macro. So in Substrate, there are few declarative macros. One is construct runtime. The other one is implement runtime APIs, add benchmark to any specific type of palette that you have mentioned into your runtime. And implement runtime APIs is another macro to provide those APIs to your runtime based palettes. Similarly, there is a declarative macro known as parameter types also, inside which you are going to mention the types for whatever types you have in your config trait into your runtime. And then these are known as attribute macros. So frame support provides you a macro which is palette. Via this palette, it is going to check the structure of your palette, whether in the structure he has mentioned something as trait config. Okay, inside the trait config, do we have types? And for any specific type, if it is a constant kind of a type, so does he mention palette constant? Or if it is an event type, so is he saying it as palette event? If it is a storage type, so is he saying palette storage? So all of these are checked via this attribute macro, frame support palette. So similarly, there are other macros which keep doing the same job for them. Okay, now palette functions. So these palette functions are also known as extrinsics. These are accessible from outside, from off chain to do anything on your chain. Okay, anyone can have access to these functions, and these are executed by signing and submitting an extrinsic. Okay, so since you all are here for understanding Substrate, I just want to know how many of you you have even done any sort of blockchain coding or have worked on Solidity by any chance, or any other language which kind of does blockchain coding. You can either unmute yourself or raise your hand.
All of you, you have the ability to unmute yourself. So do shoot in any questions so far. Okay, I guess we can continue, Varun.
Okay, why did I ask this question? Because if you remember, if by any chance anyone has come across Solidity kind of contracts, you need to write a contract. So whenever you are writing a contract, so what is that smart contract going to do? Sorry? Okay, who is going to authorize the contract? Who is going to provide his fee to even kind of deploy that contract or to call a particular function of that contract? So that key, that value, the signature is nothing but a account ID or a key of the user to say that, okay, listen, hello, I am going to call this function, and since I am doing it on chain, you can take the fee from me, and if any funds I'm getting, give the funds to me, and if I'm doing any transfer of the funds, take the funds from me. I am authorizing it. I am providing that signature. So this is nothing, but this is like signing a particular function. Okay, so that is why I was asking that if anybody has come across with this, so it would be easy for you to understand. So to perform any call on blockchain or anywhere, you need to provide an authentication or a signature to an extrinsic. Extrinsic is a call. So as I said, it is ideally decorated with a keyword itself, call, as simple as that. So from the palette, it would look for this specific call. It would generate its metadata against it that, okay, listen, this is the function call that is going to happen. Now, when we are doing this function call, who is the signer over here? Who is going to provide his account details or to provide a signature to, kind of say that, okay, listen, if this call is successful, you can take the gas fee from my account. Okay, so, and how much could the gas fee be? It totally depends. The more and more you get extensive with Substrate, you'll understand how to even estimate a gas fee for a particular function call, because you will understand that how many byte size of code it is taking in a block, how many database read and writes are happening in the block, so you can incur the charges to the user. So because you are the developer, right? So to the user who's actually calling this function to pay that much of gas fee rather than you taking care of that gas fee. Okay, so this is how you mention in Substrate palette weight. So it is actually taking, it is showing 10,000, but it is 10,000 into 10 to the power of minus 18. It is that small for a normal function. Okay, then this is a very generic pub function do something. And this that you see over here, the origin is of a type origin for T. Now this origin for T is again a specific type which is mentioned in your runtime that, okay, listen, whoever is implementing or calling this particular function call is the origin or the authority who has called this function and is also signing this function. Okay, and then whatever you want to do with that. And then we will cover this, what is T balance. And then, these are the return types: dispatch result with post info and everything. Okay. Now, coming back to the main point. So in order to write a palette, it is a very set structure. You don't have to worry about that. What all do I need to mention? It is a very, very fixed structure. There is a trait known as config. There are types known as events and errors. And there is a type known as storage. So events is nothing. Events is a notification that you are going to give to the user that, okay, whatever you performed on the block has been taken care of. And then it generated a transcript, or it generated something. I want to show it to you. That becomes a notification. It is like a transcript or a script that you want to show to the user. Okay, you wanted to add $200 to somebody. I have added these $200 and it has been performed on chain. Okay, or anything you want to perform an event, you can mention it. It's a notification. Errors are something which you can also mention in your palette. These errors are specifically for your palette. These are customized errors which you can throw if the function was not successful or something else happened. Then what the user actually, okay, something else happened, user was supposed to do something else. So you can throw that type of an error also, that, okay, listen, the amount you're trying to transfer to this specific user, this user does not even exist. The account ID that you have mentioned is wrong. Okay. So you can actually give this any kind of an error, customized error for your palette. Okay. Now, storage. Storage is something which would take value, or which would take memory in your chain. Okay. So use it wisely. Whenever you are trying to add any specific information and want to keep it for life on the chain, you add it to the storage. And even if you don't want to add it for life, you can delete it, but that storage can be removed. But once it is there for that amount of time, it is being utilized and is accessible to everybody. Okay, whoever can query that specific storage via the API. Okay, then I just already covered call. So call is basically an extrinsic via which you try to communicate to your palette. So this is the overall palette structure that we follow: config, events, errors, storage, and call. Okay. Now, okay. So before I jump in deep in this, any queries?
Guys, you can unmute yourself and ask, or drop in on chat box, or even tag us on Twitter. So if you have any queries so far, if not, we shall just
Ananya, why don't you ask them the first question?
Yeah. Okay, yeah. Great. So guys, okay, we'll make it a little interesting for you, and we are giving out, airdropping dots on you for this one, so that we know you're expressive enough. But yeah, let's have the first question on board. So the top 3 winners, what you have to do is answer, tag us on @_Polkadot India, and yeah, just shoot in your answers. The fastest 3 get 50 dots each. So which of the following is the correct syntax to implement a generic type trait for a struct? Your options are A, IMPL T palette T, IMPLT config palette T, IMPLT palette T config, or IMPLT config palette T config. So these are your 4 options. Just answer on Twitter, guys, and tag us at _Polkadot.Friday, and at Polkadot India. And yeah, just shoot in your options. Top 3 winners get 50 USDT worth of dot each. It's an easy win. Just keep them coming, right?
So do we announce it right now? Right?
No. I think we need to get some interaction out here. They are starting to take us for granted, Varun. Yeah, and let's get them to talk. Guys, get talking. Any doubts at all? Varun is a darling when it comes to answering any of your queries, no matter how basic. So do shoot in. Even if you're on our Discord channel, he's available to answer any of your queries anytime. So yeah, keep talking, guys. And
I've already covered this in the deck, guys, like a couple of slides back.
Yeah.
And thank God, I mean, you don't have the access to the deck yet, but we will share the deck once it is done so that you can go through it.
But I wish I was a developer like all these amazing people out here so that I would have got that 50 USDT worth of dots so easily. Come on, guys, get answering and we'll see you soon. Varun, let's train them some more with your amazing stuff.
All right, sure. I will then share my screen again. Okay, so getting back to this. So we went through the code structure slightly, but now let's actually see how do we see all of these things on chain, right? So as I said, Rust provides you a cargo manager, a package manager known as cargo. So whenever you want to compile all of those packages or crates together, so it's a simple command, cargo build. And so this is in order to build all of those together and then with a flag release. Okay, so it will start compiling. So I have already pre-compiled it because if I don't do it, there are 847 packages. That takes around good 7 to 8 minutes first time, only first time. So I had to keep it pre-compiled so that we don't waste much of time in compiling rather than working on the code. So let it build. So as you see, this template module, okay, I haven't written it. They have written it and they are saying that, so see the beauty of Rust compiler. Even for a normal warning, it shows it to you at a specific line inside a specific file that in runtime source lib.rs at line number 299. Can you please make it better? Can you write it in a normal format rather than, in uppercase rather than, kind of mentioning it in the camel case? So even these sort of warnings, it tells you on your terminal. It also collates all of them together and tells you that how many warnings are generated or how many errors are generated. So there are 3 warnings currently generated for your template module. Okay. And if, for example, there is a code which you are not using in your entire logic, so it would throw just a warning that it's a dead code. Why don't you use it? If you're not using it, so please remove it. So it will give you these kind of warnings as well. So once this compiles, I believe another 10-15 seconds, then we will quickly go to the chain. Okay, let me actually go to this first. Okay, so Polkadot has something known as a block explorer and also a front end created for your chain, the backend code, the node code that you have written. It's an integrated front end written already for you, via which you can see the functionality of your runtime logic or your chain, even without interlinking with any front end at the moment. Custom front end. So this is like a front end for your chain logic. Okay, once this is compiled, then it will just take a second or two to kind of run the chain. And I'll also explain a couple of things the moment we are running the chain about each and every thing that what kind of. Okay, I have an interesting question again. This might not be a rewarding question till the times, but okay, for this you won't get $50 worth of dot. So whenever you are creating a chain or initiating a chain with the initial state, what do we call it? With the initial state where nothing has happened yet, with the first block that it is supposed to be, the first block is supposed to have all of this. What state, what is that state known as? You guys can provide messages or chat, like your responses in the chat itself. This should be interesting. I believe most of you should be aware of this.
Guys, you can also raise your hand on chat if you get that option.
Exactly. So I believe Sakshi has said Genesis block. Perfect. So correct, Sakshi, that's Genesis block, the first block, which is having your entire logic from the chain, and the first block is known as Genesis block. So I'll show that to you on the terminal itself. So, okay, in order to run your chain, so you need to tell that where is my binary located. Okay, so my binary is located in my cargo package manager. It's going to search for this binary, which is at node template. Let me cover that actually. So you see the moment I did build release, so inside release, okay, so there should be a folder as target. Okay, so you see this is slightly grayed out. I mean, you can't make changes to this. The moment you did cargo build release, it creates a folder on its own. Okay, the cargo package manager with all of the binary logic of this particular node and runtime and the palette. So when you go to target, so inside target, there is a folder as release. So for release, it would look for node template. So this node template, this is your binary that it is going to search. And based on this binary, it is going to, so again, if you come from Ethereum background, so you generate an ABI, right? That ABI is nothing but a binary. And this target release node template, inside this, you have your, I won't call ABI, but that's a binary of your entire block. Okay. And then you give a flag as dev and TMP. Dev flag is to tell your node that, okay, the chain specification that I'm going to provide, it has few flags. One is a development flag, which is dev. The other one could be a test flag. The third could be a local testnet flag, or whatever flag you want to define. But by default, it is a development flag. I'll show it to you that where can you find that. So in chain spec, so it is mentioned with dev. And over here with -- TMP, you are saying that, listen, I want to create a temporary chain at the moment. Okay. So once I close this, so you start the Genesis block again. You initiated the chain again. You don't have to hold the storage and values and everything. It's a temporary chain. Okay, once I enter this, now see, okay. As it said, running in dev mode. Okay, and chain specification is development over here. And this is your local node identity, your identity. Okay, not an account ID, your node, your system's identity. Okay, currently highest known block is at 0 because it has just started. And now this node is listening to the front end for new connections on this port 9944. So you do localhost 9944, it would be just listening to this specific chain. Okay, so the front end that I was showing it to you, inside this, there are, okay, again, I'll go. So you see over here, these are the networks which are mentioned. Okay, Polkadot parachains, Kusama parachains, test parachains, and then you have live network, test network. I currently want to connect to my local node, which is running at this 127.0.0.1.9944. If you want to change the port number, you can change the port number and make it custom and provide the port number over here. Okay. Now, in Substrate, in the development flag that I showed it to you in chain spec, there are around 4 accounts that they have provided funds, which has around 1.1529 million units. You can provide funds to others also, but you need to make changes into the chain specification file for that. Now, coming to the extrinsics, as I mentioned, extrinsics is your functions where you are mentioning all of that. Okay. Under developer, you have extrinsics. Under extrinsics, this is where you have all the palettes via which you are going to do the transactions. So if I click on template module, so if you remember in my runtime, I showed you an identifier of a palette. So it was written as template module : palette _ template. So template module is the identifier which is currently linked via your runtime and provided to the front end. Okay. In template module, there is a function which they have written. I mean, in the template, I just wanted to show you how it works. So there's a function known as do something. Okay. Since they are forcing us to do something, we'll do something. We'll write 12. Okay. Now, as I said, for any extrinsic to be called, somebody has to authorize this transaction. In order to authorize a transaction, you need to pay a fee. Okay. Now you are going to pay a fee of 125 micro units. Micro is 10 to the power of -6 units to even, just do something, which is 0.00000125. Okay. So from which account do you want to sign the transaction? From Alice's account. Now this is the call hash. This call hash is nothing. So this something that you see, okay, this value, this has been encoded by Substrate. There is a crate known as codec. So codec basically helps you to encode and decode your any value with a hash value. Okay, because you don't want to show your value to everybody on chain, right? That I'm doing something which is 12 as a value, or I'm transferring $1,000 to Varun. If you want to, please do. You don't want to mention that. So you encode that by using scale codec, and that is a hash which has been generated. Correct. Now, the moment you do this submit transaction, now it is asking for your sign and submit. And then the moment you do this, it would deduct this much amount of fee from your balance. So if I do sign and submit, okay, over here, you see, this is the event that was triggered, something stored. Template module, something stored. This is an extrinsic event. Now, where do you see these events? Come under Explorer. In Explorer, you see, we did only one event, but two events have happened. One event that we did was that we wanted to do something which was 12, okay, as a value. But then there is a second event which has also happened, which is balances.withdraw. Okay. So, which is balances.withdraw. Now, balances.withdraw is an intrinsic event which has happened because you paid that fee, right? You paid 125.0001 micro units. So this is the event that has also been recorded on chain, that, okay, Alice actually paid this much of fee to call this particular function, which was doing something. Okay. And where did it happen? It happened at block number 41. So if you go to block number 41, you can see what all happened in block number 41. So all of this happens over here. In template module, do something. What did you do? You did this 12. Who was the signature? Like this is my ID, Alice's account ID. And this is the hash which is generated for that particular function call that you did. And these were the events that happened. Okay. And then there is something known as chain state. I'm not sure whether, okay, they do have. So chain state is the storage that I was mentioning it to you, right? So whatever you want to do and want to add it to chain permanently and store it in a in the heap of the chain to, kind of query it later to see if you don't know the block number, at what block number, what happened. So you can directly call it via that storage. I don't think, okay, they have this. So we'll see. So see, something from template module, which is a U32 type, return me that value, which is 12. So if my front end wants to query the chain, so there is something known as Polkadot API. That's a separate topic out of the scope of this meeting and this call at the moment. So via Polkadot API, you can actually do API.query.template module.something that would return you that value 12. That value 12, you can show it to the front end. Simple. So this is how you actually create a DApp querying your Substrate code base. Okay. So now let's actually, I would stop this, the chain, and let's understand the flow now. Any queries in this understanding?
Guys, you can really unmute yourselves and feel free to shoot away any questions at all, or simply drop it in the chat box.
Okay, so I believe we have no questions. So I'll walk you through this palette that is a default palette, a template palette, which was given by Team Substrate, right? So inside this, you have from frame support palette, this is your macro that you're calling. That macro is ideally going to check everything, like how do you define a palette and all. And inside that, you created a module. Module is, again, something like a class, but don't take it as a class, but it's a class inside which you're defining each and every type and the function. So you write it as pubmod palette. And I want to utilize these dependencies from frame support, which are coming from the Substrate code base. I don't want to write it again. I'm just calling those. Okay, so these are your, what should I say? Okay, library dependencies that you can call for easy functionality. Otherwise, if you want to write it from scratch something, you can definitely do. Okay, so we'll understand this when we keep doing it. This is the way they write it, frame system, and double colon is basically to call a particular type mentioned inside a particular package or inside a particular. So for example, this is your module. Inside this module, you want to call all the different traits that are mentioned inside palette prelude, or all the different types, or everything that is mentioned inside palette prelude included. Okay, this is basically your include in my package, which is this palette. Okay, then you have a trait palette config. So this by default, as I mentioned, is the name as config. Ideally, when you are writing a palette, you can't change it, because this config that you see over here, this is actually looking at this config word. If you want to change the name of your trait, then your palette won't compile, because currently in Substrate, the palette word that I showed it to you, right, that is looking for this specific keyword, and this becomes a value for it. So if you change this value, this key needs to change. And this is a macro which is written by Substrate. So ideally, you don't change the name of the trait. You keep it trait config as is. This is bounded to frame system config, where you have a type event mentioned, right? Now, what is it doing? This is so tricky. What is it trying to do? This is an event type which I want to create for my trait. Okay, I want to create an event type. Now, this type of event is actually dependent or bounded to my event first and foremost. Now, what do you mean by my event? So you see, from event self is my own event, which is this event. Okay, it would look for this event in this module. Where is this event? This event is already mentioned over here, the inner event, right? So my event is not only bounded to this event, which is my type of an event, but is also dependent or along with needs the functionality of frame system config event. So whatever is implemented for frame system config type, I want to include it for my event also to make it more generic. Okay, if you don't want to include it, don't include it. But usually when you are doing a type bound, you have done a type bound over here. So you will mention that my event type, which is an extrinsic event also coming from frame system, which you are going to show to the user, is not only dependent or not only going to emit this notification, it could also emit a notification coming from this frame system config. Okay. Then this is the decorated view of writing a store via which you can, kind of add storages. So you generate a store for a specific struct, which is palette. Okay, that storage is known as store, but inside that you can have storages, right? Various storages. For each and every storage, you will have to mention with these decorators, or if I call it as attribute macros, I'm calling it decorators because usually we decorate it with the main logic that you are writing. You decorate with these lines on top of that. So you can call them as decorators, but in logically, they are known as attribute macros. Okay, so you are going to call palette storage, which is again a macro that your node is going to see, or basically your Rust compiler is going to see for your construct runtime, which I showed it to you, right? Construct runtime is going to look for the entire palette. Palette is going to look for palette storage, palette call, palette event, right? And then this is the basic definition in order to get the function, which is a get function. So whenever you're writing a function, you say ABC get, okay, or get something from this. So you obviously do get, put, post, and all that, right? So this palette getter by default generates a get function for your storage type that you are mentioning it over here. Now this is the storage type that you have created, something. But if you want to call it via a particular function, so you can separately call it via the function also, or if you want to call it via this, so you can call it via this also. So this is kind of an alias, okay? And then there are few different storage types. One is a storage value. If you just want to store a value on the storage in your memory of the chain, blockchain basically. And if you want to have a storage map which has a key value pair, for this specific key I want this value, so you can call it as a you can use storage map. Then there is a double storage map to have a tuple of a key and then a value. So there are multiple ways, we can cover a couple of them. So this is how you write a storage. And then the earlier event that I showed it to you over here, event, right? Now this is also decorated with event. Now this event over here is going to call this specific macro, generate deposit, to look for this event, deposit event, okay, which is having a type enum for event. Now when you are saying enum event tconfig, so for your trait that you are bounded with config, this event is the one that I want to include in my config trait for this overall event that I've created over here, right? So it is a very, very basic structure to write an event, the name of an event, and the types that you want to throw or show to the user in an event. Okay, so always remember, you can't just say that I want to, kind of give this variable as the event. Whenever you are creating an enum type, or whenever you're creating a struct type in Rust or Substrate, you obviously need to tell that this event type is going to have the types of these primitive types, account ID, balance of, or U32, U64, or whatever. You can't provide the variable name that that something, right? We saw something 12. So that something 12 is nothing but U32 actually. Okay, something stored that you saw, that U32 was actually giving you value 12. Okay. Now, as I mentioned in the one of the slides, that there's a structure that you need to follow for events, errors, and then calls, right? So you can have your own custom errors to be thrown whenever something wrong goes in a function call. Those errors, you can mention it over here, okay, inside this. And now over here comes your main logic, main function, which you are going to use in order to do any functionality from off chain to do any kind of a thing on the chain via this particular function call. Do something or anything that we are going to write now. Okay. And this is where you actually define the weight or the gas fee that you are going to charge to the user. The one which we saw that Alice paid 125 micro units, correct? So this was the base, but then it did a DB read and write. So the value increased. Okay. That is the reason it was not 10,000 micro units. It was 125 something micro units. Okay. And then this is your function call. You provided this. This is the dispatch result. Now, who is going to sign this? And this is how you update the storage. So the name of the storage and the generic type that you are going to do, and what do you want to insert into that storage. So what do I want to insert into the storage? The value that I got from the user, I want to store that into the storage. And then I want to call an event or an notification to show it to the user that, okay, this event, which is something stored with this value, something that is coming from the user itself, 32, and who provided that value. Okay, if you don't want to write it as something stored, something, and who, you can remove who, you can just show something, okay, as the value. And then you need to change that definition over here. So you can just remove the account ID and you can show only the value rather than the account ID also. So this becomes your overall structure of the palette. Okay, now This palette of yours need to be included in runtime. I've already covered this, but the types that you have specified separately, they need to be provided to the runtime. You haven't provided the type. You have just provided that, okay, listen, I want to add this module, which is palette template. Okay. Now you need to, because see, you need to implement those types that you have created. You created a type. I showed it to you inside trait config. We created a type. Okay. Can somebody put it on chat? What type did we create? I need the answer to this.
Guys, if you can fill in. I wish we could drop about 100 dots for this response, but unfortunately not. Guys, like just respond, yeah? There's nothing right or wrong over here. So why don't you just put in your inputs?
Can I repeat the question once again?
So inside our trait config, we created a type, correct? We created a very specific type, which was also bounded to my own type, but was also dependent on frame system config type. Now, when I added this palette template, so in my runtime, I'm telling, okay, listen, I want to add this palette, but for this particular palette, I have separately mentioned a type. I need to implement that type. I need to implement that type for runtime, which is my enum over here, because I need to tell the block that, okay, listen, whatever primitive types you have, that is okay. I need you to include my type also. Listen, my type also. So yeah, what type is it? Correct, user defined, but what was that type?
Manindra says structure. Abhishek says enum.
No. Okay.
Config by Jaren.
Event. Who said
Events
event?
by Manvendra.
Okay,
yeah.
okay. So Manvendra, you're right. I'll just walk you through it again. Looks like there is some amount of confusion. So if I come to my template over here, in my config, the trait that I have defined, my trait, okay? So there's a behavior, there's a property that I have defined, event, okay? This event, I need to tell the runtime, okay, in your block. When I say runtime, this is the file runtime, which is mentioned inside runtime. Okay, there is a palette template that you have included. I want to implement my type also for this runtime to which you are bounding the block with. Okay, so probably this will make it more clear. So if I look at palette template, see, implement palette template ka config is my trait for the runtime with the type event. Okay, this is the type event that I am defining. This event is equal to event, but this event is also equal to the frame system config event. Okay, this might slightly be tricky. Okay, we'll cover something in detail. You can ignore the frame system config type. So you would be saying that where have you defined this type event? Okay, I haven't defined this type yet, but I would be creating custom types. But this event is already defined by Substrate in frame system config. Okay, I'll show it to you. See over here. This is, I didn't write this for my palette. This is frame system config. This is provided by Substrate, frame support, frame system, right? They have their own trait config. These are so many types that they have created. Now, for their type event over here, they have a type event. Okay, so I am actually saying that my type inside palette template, which is palette template, my type of event, which is this, is equal to frame system configs event. Keep it as is. I don't want anything extra. Just give me that event type. Okay. Why do I want only that specific event type? Because I've already mentioned it in my config inside my my palette that my type event is of type frame system config event separately over here. Plus, I'm also doing whatever is part of my event. Okay. Which was, where did it go? Where is my event? My event. Does that make sense? Okay. I'll move forward now. So let's come to our lib.rs runtime. So this is where you define a particular event. Okay. That's how you overall package an entire palette and put it out in runtime. And now I actually want to do hands-on, but to be honest, I am not able to get the participation that I'm looking for. If you guys are genuinely interested to learn, we can actually write an entire palette of our logic from scratch. But I need certain help from you guys as well. We need to have the conversation on this.
Yeah, sure, Varun, we should go ahead with that. We would love to see that. But I have a question. The
Sure.
type thing that you explained here, is it kind of overriding that we did here?
No, we are not overriding it. We are actually appending it. We are enhancing it. We didn't change the logic of frame systems event. It's not overriding, it's overloading. I have overloaded the event.
Okay. All right.
Yeah.
Like we change the behavior of the event, kind of.
It won't change the behavior of, if it changes the behavior, then it would throw an error. Because see, for something to change its behavior, you need to change its base version also. I'm not changing the base version. I'm not changing the behavior of frame systems event. I am just overloading my event with whatever is the base version created by frame system, and I'm advancing it with my event type also.
All right.
Yeah.
Varun, a query by Abhishek is that the understanding the concept and the technical side of it is getting a bit much. So how do you want to address that?
I understand. See, I'll be very, very honest on this. Understanding Substrate code base for the first time is very tricky. It is steep. It is definitely steep. You need to sit with the code for around a week. I would be honest about it. You need to sit with the code for a week to look at each and every word, that where is it flowing and what is it trying to do. The moment you understand the overall logic, then it would be very easy for you. See, for example, right now, the way I am trying to explain, why is it easy for me? Because I have genuinely spent a lot of time with the code. So that's the reason I told you that, okay, this is the template where I'm writing the logic, and this is where I need to actually call it. For you, it might get some time to get adjusted with this whole notion of writing something over here, providing that dependency on somewhere else. If you are a developer who has done some coding, tell me one thing honestly. If you have created any code base on your own, listen to that question very carefully. If you have created a code base on your own, if you give that code base to a new person who's a new developer and just tell them, okay, go through it, read it on your own, and tell me what do you think about the code. Do you think that it will be easy for the person to even understand what is happening in the code base? Just be frank, just be honest.
And you can unmute yourself and talk or chat.
Yeah. No, we won't be able to understand.
Exactly, because you don't know what because the other person doesn't even know the functionalities. But now be honest to yourself, because I am honest to myself over here. Even if I look at my code base, the one which I had written from starting to end, after 7-8 months of not touching that code base, and if I look at it, I would still get confused. Okay, what the hell have I written and what the hell has happened over here?
Correct. Yeah.
Right. So in order to develop on something, you definitely put in a lot of effort in order to kind the overall flow, the logic, what is going where. At the end of the day, I won't use the term object-oriented over here because it is wrong. But if you are coming from an object-oriented mindset, so it is genuinely very easy for you to understand at least the flow. Once you understand the flow, you will definitely understand the overall game of traits and types. Substrate and Rust is purely heavy on traits and types, nothing else. Once you have been able to figure out traits and types, you would love Rust. It is one of the best languages because, as I showed it to you, only few of the languages have such an amazing compiler to even show you the warnings, to even show you the errors even during the compile time itself. One of the very limited languages, and it's genuinely very fast. That's the reason I personally love Rust. I'm happy we had this conversation, and
Hi, Varun.
Hey.
We are totally new to the Substrate world. So this is my first video, and going through your previous videos as well. So what do you say? The participation, will definitely be participating in the future events. Means we are learning currently.
Sure. See, the whole point is, in order to learn from anybody, I am hungry. I am one of the most hungry person when it comes to learning. I want to learn everything. And in order to learn, always remember, ask questions. There is no harm in asking questions.
Okay, Varun.
Okay.
Right.
By the way, if you guys are feeling that I'm scolding, I'm not scolding. I'm just trying to have a normal conversation. Because even we learned it that way. Even I learned it that way. Nobody taught me Substrate. Nobody taught me Rust. I went through all the books. The kind of curriculum and the kind of material that we are providing it to you is.
Could you please suggest books?
For Rust, I can suggest books. There are no books on Substrate.
Okay.
For Rust, we can share the links with you. You can get all the books, all the support in Rust, and Substrate only pure and pure via the documents that Polkadot team, not Polkadot, Parity team has provided.
Okay.
So one question, Varun.
Sure.
So I am also trying to make sense. I am coming from object-oriented background, and this is my first video as well. So trait, I can relate it to abstract classes.
Correct. Bang on.
Okay, cool. Thank you.
Yeah. See, I didn't use these words janbujke. The reason being, shit, I said an Hindi word. I didn't use that word. What should I say? Purposefully. Purposely is the correct word, actually. I didn't use that word purposely because everybody's coming from a different background, right? From different type of language implementations people have come up with. So not everybody has abstract classes. Not every language has abstract classes. That's the reason I just kept it very, very generic in order to explain that you can assume that it's a class, but it is not a class, it's an abstract class. It's an interface, you can also say. It's not a class, but for generic purpose, it's a class which could be utilized and called in any specific module or any specific other class, other palette. So if you guys continue learning, we might do an interesting session of coupling of palettes. Palette coupling is the best thing to do because see, first and foremost, why are we learning Substrate? The main reason is I don't want to spend that much of time to even write the networking logic or the consensus logic. Okay. If it has already been taken care of, I don't want to worry about that. Okay. So when you have 36 pre-compiled palettes, so there are currently 36, if I'm not wrong, or 37. These are the palettes which are provided by Parity team Frame. Under Frame, you have all the palettes. Okay, let me show it to you. Wait. Okay, Parity Substrate. Yeah, so I was saying again and again, frame, right? So this is their overall code base, which has around 30,000 lines of code. This is the entire code base, by the way, Parity team's Substrate code base. which has everything. So when I say frame support or frame system, so I'm actually calling from this frame. So inside frame, you would be having frame, frame system, frame support. So as I showed it to you, frame support config or frame system config. So from this frame system, I am calling from my source lib.rs, there would be a config trait. Okay. Oh, sorry. Config. See, I'm calling this trait config. So see, I am bounded with their logic, their provided trait, okay, which is part of frame system that, frame system config that I showed it to you. This is coming from here. I didn't write that. Okay, so whenever we are including these packages from Substrate, and where am I actually providing these packages? So if I go to this, and there is a runtime cargo.toml. So over here, see, okay, can you see this line? Frame system. So I'm saying my frame system, which is currently this, I want this version from the GitHub repo, which has default features equal to false. And if I go to Git, okay, I want you to download this particular folder, okay, this particular code for frame system and give it the name as frame system. This frame system, I want you to include it into my runtime. I have mentioned it into my cargo.toml, correct? And the moment I did cargo build release, it would download this package for me. It's binary for me. And where is it going to store that binary? In target release node template, the one which I showed it to you. So, I mean, that's the overall flow.
So one question, Varun.
Yeah.
So does this gives us flexibility to include codes from other into our module? Like
Yeah, totally. There are, but it should be at least Rust enabled code, because cargo is a package manager which is going to look for that cargo file, right? So even whatever logic you want to write, there are different open runtime libraries also, which you can include in. Okay, I can show that as well to you. So ORML packages. Okay. Runtime. So see, this library that you see, ORML, this is not created by a Parity team. This is actually a community work. A lot of developers from different projects have contributed in this repo, which is known as Open Runtime Module Library. From this, if any palette or any code is not available from Team Parity under Substrate, so you can still call this particular code from ORML library, add it into your cargo.toml, and whatever functionality this code base provides, you can definitely leverage.
Yeah.
So see, in frame, you don't have NFT. In frame, you have assets. Frame as in from Parity team's Substrate. They don't have NFT as a separate palette. They have something known as assets. You need to customize that in order to make it an NFT. But if you don't want to waste that much of time, if you are able to find out somewhere where the NFT is, in Open Runtime Module Library, somebody has already written a palette for you, NFT. Okay.
So one additional question on top of it. So suppose if I am using somebody's code into my into my module, and I compile one smart contract and it is running, and say in future that module is removed from the GitHub repo. So what will happen in that case?
Nothing. You can. It's always better. It's always better to fork that particular code base into your repo with that specific version number. So it will always stay with you, right?
Right.
Wherever. So you can give the path of your GitHub repo.
Yeah. Okay, cool.
Yeah.
Okay, Varun, before we proceed, we kind of have a couple of questions that have been pending. I
Sure.
have precisely 2 for you, unless you've covered it, of course. So we have Sabyasachi, who says, how do we know, sir, where things are going or getting filled, basis all the entries you've made? So is there any response?
I genuinely didn't get the question.
So whenever you've made fresh entries in a template, how does the user know? Like, how does the coder know where it's going? It's by Sabyasachi. Sabyasachi, you can feel free to unmute yourself and clarify this, please. Okay, I guess Sabyasachi is not around. So the question literally goes like, how do we know where these entries are going or getting filled?
Okay, so
The chat, I think he's put up.
yeah, I can see. So he said when you showed how the things are filled. I am not able to get the question. If you can come on audio, it will be brilliant, but I would try to answer with whatever I can understand. So you are saying that the palette template that you showed it to us, right? And whatever types that you had defined, how will we know that where is that logic of palette template of any specific type needs to go inside which specific section of runtime, correct? Is that your question?
Yes.
Okay, okay. So you'll have to sit and play with it. That's the answer. Otherwise, you need to develop something because see, at the end of the day, whenever you sit with the code, the structure you understand, you will definitely get a hold of it that where is the logic even flowing. As I showed it to you, for me, I make changes in this. There are only 5 sections that I need to worry about. One is the config trait, the other one is the event, the other one is the storage, the fourth is the error, and the fifth is the call. This completes the entire structure of my palette. Okay. Anything outside this would be the dependencies, or if I want to include a structure, or if I want to include global types, which are not part of a specific event type only, or within the trait, I want to just keep it within the module. So I can do that. All of that just goes inside the implementation part, like this implementation part for my runtime. Runtime is an event. Oh, sorry. Runtime is an enum. Okay, which is going to get configured with the palette's config traits and those types that you are defining that are included into my runtime. This is the overall flow. There is no other flow at the moment that you need to worry about. Once you are able to understand this flow, once you get the hold of this, then is the time you will be able to play around with the node folder. This is where the actual magic also happens. So I totally understand you guys are seeing it for the first time, and I don't want to overwhelm you with a lot of information. So that's the reason I might stop it here. But I would advise if you guys want to go ahead, so I'll go ahead with at least one folder, which is change spec file, where you can see that what happens during the block, what happens, what gets included in Genesis. How do you even give funds to a particular account? Okay. If you guys are interested, I'll cover that piece rather than rather than writing a template. If you guys want, let's actually do one thing. I don't mind. I can do one more session. To be honest, I can do one more session purely on creating a palette from scratch. Let's keep a separate session for that because I believe already a lot of time has gone in this. I would take the entire responsibility of doing one more event only for you guys, but I want all the contribution in such a manner that you guys are already learning and coming something. Because next session, I would be asking few questions on whatever I have covered today, and then on whatever material we are providing it to you, because there is something Polkadot pathways that we have shared with you. Ananya, right? We have shared Polkadot pathways.
Yes, we already have in the previous sessions. We'll again be sharing it in a short while. Okay,
so before the next session, which might happen probably in the coming month after 15-20 days. So in those 15-20 days, please, it's a humble request to all of you. finish off at least the learning. Don't build. If you can't build, don't build. Because I understand the moment you're trying to build, you might face a lot of errors. Understand how to even learn Substrate. There is a separate section as learn. Okay. Inside learn, you have learning the concepts of Substrate and also learning the concepts of blockchain along with how it has been implemented for Substrate. Once you're able to cover that, then if few of you are able to even find out some time to even build, go to the build section and learn how to even, build a normal node or a normal palette. For that, I can give you one more thing, which is pure gold, which is this substrate.dev. Okay, I've already shared that link with you. Under substrate.dev, it is a humble request to all of you, just cover at least 2 or 3 tutorials from this so that you understand. Because see, no matter how much I try to explain, unless and until you don't try on your own, you don't sit with it, you don't make mistakes, you don't make errors, you won't be able to understand 100%. Okay, at least do the first one, create your first substrate chain. It is genuinely it will take only less than 1 hour if you follow this. And then add a particular palette. Don't worry about writing any logic to the palette. Don't worry about writing any function in the palette. Don't worry about writing any changes into the next palette. Just try to add this palette into runtime. The way we added this palette template module, right? This template module is nothing but we have added this template module into runtime. So if I copy this entire palettes template ka folder, add this inside this, it would create one more new palette. That palette could be added over here under runtime. And that under runtime, you need to just provide it for your runtime that this palette needs this config for runtime and the types. Just try to add this much. If in 15 days you're able to do this, trust me, the next session that we are going to have, that will be just amazing. I mean, you guys will enjoy coding in Substrate and Rust.
Guys, just to get an understanding, how many of you are actually listening, are actually interested, and how much of you are pumped, right? So just give us a raise of hand in your emotions. Thank you so much, because that's what keeps us motivated, keeps Varun motivated to come up with even more better curriculum. So great. Thank you so much. Thank you so much.
Okay, I'll just take 5 minutes of yours in order to explain the chain specification file that I mentioned, that what goes inside the node and the block. Okay, so if you remember, I said that we write the palette logic, we add it into runtime. Now we need to add that runtime into the node. Okay, node as in to the block that we are going to add this. So you see this node template runtime. We are calling this as a dependency that you include this node template runtime. Where is this node template runtime even coming from? This node template runtime is nothing but it's the name of the package runtime. So in runtime, your cargo.toml, right? You see over here, this is the name, node template runtime. So use this package. This is what you're saying to the chain spec. Use this particular package. Okay, inside this package, whatever is mentioned, I want all of that. I want account ID, I want Aura config, balances config. These are the configs which are separately mentioned in your runtime. Okay, then I want you to include all of these things as well. Okay, now, whenever you are trying to create a chain specification file, in that chain specification file, include this Genesis config. Okay, now what does this Genesis config have? Now, if I go to this Genesis config, you see this function testnet Genesis. This testnet Genesis is returning a struct, which is a Genesis config. Now this Genesis, this is a struct, so it holds a lot of things, a lot of fields inside it. Okay. I just want to show you one small thing. So see, testnet Genesis is a helper function which you are going to include in your Genesis specification file. Okay. And if you remember, when we were launching our chain, we said dot target release node template space -- dev -- tmp. That -- dev is the ID that we are giving for our change spec. So for my change specification, which is Genesis config, I want you to include this development config, only this. I don't want to include any other ID. I don't want to provide it for local testnet. I just want to run it with this. So it will only focus on this. It won't focus on the local testnet config. It would just focus on your development config. So we provided this flag dev, right? Now this dev flag is calling a function testnet genesis. Inside testnet genesis, you see, there is a single account which is generated from seed as in there is a keyring. I don't want you to listen to all of this in a different tangent. Just sit with it, just listen to it. Okay, don't think too much that where is this get account ID from seed coming, what does SR25519 mean. These are all going to be covered probably in the next session, or maybe when you start reading on it in detail, because this goes slightly in depth. So what we are trying to say, that there is going to be a root key, which is Alice's account ID. From Alice's account ID, I want to generate few more account IDs, okay, from the keyring itself, which are these four. To these four account IDs, which are stored into the vector, I want to give them some funds. Because see, we came under Genesis config, right? What is the fund that you want to give it to them? Over here under balances, these are the endode accounts. Iterate over all of them, map the account ID with this value. This is the balance. So you are mapping the account ID. Okay. This is the closure, the way you write the closure, right? So you are giving that particular account ID this much of balance. Now I want to show you one thing. If I change this value, if you remember these four account IDs, Alice, Bob, Alice Stash, Bob Stash, they had 1.1529 million units. If I change this value to something lesser, okay, let's see how much is it going to give the value to each of these. Now we are playing with the change spec file. Okay, we just changed the balance these people are supposed to have. All of you remember, right, that they had 1.1529 million units.
Can I answer for all 55 of them and say yes?
Okay, thank you so much. Okay, once this compiles, I'll just show it to you that the balance would have changed for these four accounts. These four accounts which are inside this vector, right? Inside this testnet Genesis card, dev wala flag. So the moment you give dev flag, it would look for this particular config, and only these four accounts would be funded with whatever the value is generated from one left shift operator 42. Ideally, one left shift operator 42 should give you something around 2 to the power of 2, maybe, because it's 4 and there are million units which are supposed to be taken care of. Okay, don't just ignore whatever I'm saying. The value will change. Okay, Ananya, did we ask, how many questions have we asked already?
We are on only one question so far, so we can go for the second.
Oh yeah, please go ahead.
Okay, guys, here's your second question for today. And this is basis all that you've been listening to so far, and maybe not. So here, the top 3 answers, tag us at _Polkadot India with your answers. So what is the default function for calling an event if type? A, get _event, event type. B, generate _event, event type. C, call _event, event type. Or D, deposit _event, event type. Guys, just tweet your answers, tag us, and just ABCD will do. And top 3 answers, tag us and tag a couple of your friends who are non-followers if possible. But yeah, the top 3 winners get 50 USDT worth of dot each. So come on, guys, easy win. You can do this.
Okay, I'll share my screen again. Okay, so it has been compiled. Now let's run the chain with that dev flag that I showed it to you, right? So, okay, now let's just connect. to the Explorer. Okay. Okay. So if you remember, I said it was 1.1529 million units. Now all of these have been dropped to 4 units. They by units it means 4 tokens. Basically now they have only 4 tokens of your chain. Okay. So overall it drops down to 444, and the total issuance is the total circulation of your token type or your token in the chain. Like overall, it is going to be 17.5921 units. Okay. So yeah, I mean, this is how you can make changes to the chain specification file and keep playing with it. I believe I would like to take any further questions if you have. I didn't expect that I would be taking this much of time just in order to explain. I had already planned that we would cover a palette, but this is good. You guys will get some time to sit with the code, understand certain concepts of Substrate and even Polkadot ecosystem for that matter. And then let's have a brilliant next session where you guys ask me so many questions that I'm like, okay, why did you guys even spend 15 days in order to learn so much? I don't know that much, right? And I mean, just wow me with your 15 days of hands-on experience if you can. And yeah, I just have one announcement. On 4th of March, we have a very interesting session by the main core team member of Parity, the creators and the founders, you can say, of this framework Substrate. Okay, Team Parity is the one who has created this entire code structure for a lot of chains, but currently Polkadot ecosystem is extensively using it. Okay, so there is a speaker coming from their end, Sasha. Sasha would be taking a I don't know like how long the session is going to be. Do we have already the time slot for that?
We don't have a time slot for that. We are going to keep it open as to how interactive the audience is again. But Sasha has a lot to share about why Polkadot came about with the whole framework of Substrate, why Substrate is important, and why the entire ecosystem of this entire thing has been created. So I think this is going to be great. We'll keep it open for now, but we're going to have it at least for a 2-hour session.
Okay, perfect. So guys, just watch out space for more knowledge about Sasha's event. But trust me, it is going to be brilliant because the actual creator, when it comes to speak about their own framework, their own code, and give you that entire knowledge upfront, so it is going to be a brilliant session. Do attend it. And any questions for today's event, any questions even on next session that we are going to have, we are open to answer. You can raise your questions on Discord, and if any one of you want, you can ping me on LinkedIn also, and we can take it forward. So I would like to end today's session over here. And any questions, any knowledge that you want, or anything you want to discuss, we still have 5 minutes.
Varun, before we open it up, I think we had a question sometime back by Yogesh. So I'd like to bring that forward for now. So Yogesh says that in Solidity, we have view in function so that we get called that doesn't have cost. How do we do the same in Substrate is what he asks.
Correct. So there is a decorator known as transactional. Transactional is a attribute that you need to provide to a function on which you don't want to charge any fee. That could be as a helper function that you would be utilizing inside your any extrinsic call.
Okay, great. Yogesh, I hope that really helps you out. Guys, really open. Our Discord community is not for Elon Musk. It's for all of us beginners who are trying to learn from each other. So keep talking. keep asking. There's nothing wrong in whatever you ask. We are very sure that you are practicing on your own nodes, right? But at the same time, we are, like Varun said some time back, so we are giving you a private access to Parity, or rather Polkadot's own ecosystem, which is called Polkadot Pathways. So that's something that will help you learn more about Polkadot, Kusama, and the Substrate ecosystem. It will help you get recognized for your efforts with points of reputation, and even connect with other members who think as ambitiously as you guys. So just keep interacting, keep looking into these links. So let's share this link with the community on chat, please, for Polkadot Pathways. Right. And as Varun said, we're always in touch. Keep asking questions, stay in touch with Varun, and we have our other mentors like Lokesh as well, who took the previous bootcamp. So keep talking, guys, keep asking. And yeah, we also have some interesting giveaways, of course. We have shared a couple of assignments in the past that you can still attempt for your own good, just as a practice session. And just get in touch with us. We are going to shoot out some more tasks, which Varun will recommend, of course. And this will all get you through, through the basic practice game of getting into the Web3 building world. Right. So, and also, guys, apart from what we are doing right now at Substrate Saturday with Varun and getting into the developer side of things, we also sometimes get in touch with the global leaders who are actually making it big and actually have built projects, right? So this is something we do at Dot Friday, where we talk to these leaders who have done it all well. And the next one is about Metaverse. So I think anyone who's interested in Metaverse, no matter how much of a bear time this is, very downside of a time for all of us, but it's a great time to keep learning, because once things shoot up, we'll be just about in time to implement things. So guys, stay in touch. Let's keep talking. Let's meet if COVID allows it to. And yeah, just stay in touch, keep asking questions. Whatever Varun has shared today, we'll be sharing a recording with you in the coming few days too, along with the previous boot camps. And also what you want to learn further, like what Varun and Lokesh have covered so far, is the fundamentals. So if you want to grow further, if you have attended all the boot camps, and if not, please do revisit all our previous boot camps so that we can take you to the next level. Let's get to the next level of things so that we can plan it out. So if you have something specific that you really want to learn in the zone of Substrate, Rust, and Web3 blockchain project building, do share with us. Yeah, we are always game to take things forward over there. So that's about it. Varun, do you have anything else to share with us before we wind this up?
No, I just want they keep hacking on it. I mean, pick up Polkadot Pathways, rip it apart, and kind of get the entire juice out of it for our next session, so that we can have an amazing time in order to build together. Because I want to build it together. I can't do it all by myself. I want all the knowledge sharing to be happening two-way.
True.
That's it.
And I won't think twice before saying this, but we from Team Polkadot India are an ambitious bunch of people. We love learning, and we hate it when we know that all of you love learning but are not talking to us about it. So please get talking, guys. And yeah, let's just get this community growing together. Okay. And just a couple of reminders. You still have that quote tweet contest going on. $50 USDT worth of dot each is an easy win, just saying that you were here at this event and you probably took away something productive from you, right? And also, if you don't mind, can we shoot out the next quiz question, the final one for a $50 dot win? Come on, yeah. Let's go for this. On screen is your question 3 for the day. And all you have to do is tag us with your options, A, B, C, or D. So this is your final question, guys, for today, before we meet again in the next bootcamp. So which of the following is the function to get all the values from a storage map for a given key in Substrate? A, get underscore values underscore for underscore key. B, contains underscore by underscore key. C, get underscore by underscore key. Or D, contains underscore key. So guys, A, B, C, or D, just tag us at _Polkadot India with your answers. 3 top questions, 3 top answers, 50 USDT worth of dot each. Just stay interactive. These are just gimmicks to just keep you talking. So, hey, just stay talking. We have lovely mentors like Varun who will answer anytime on Discord. And guys, do join our Discord channel if you're not on it already, because you can really exchange ideas. You can really start coding together. Yeah, Varun, I think they're all yours again.
Sure. So yeah, I mean, see you guys on 4th at Sasha's event. And then after the response that we get on Discord, we will do one more session.
Yeah.
Sure.
Thank you all. Thank you all for being such a great part of this. And apart from the coming sessions, so we'll also see you at the Metaverse chapter of Dot Friday on the 20th of March, right?
Sure.
Good evening. Have a great evening all.
Have a great evening, guys. Thank you.